Hi, my name is Bryson and this is my final project on the analysis of a quarter car suspension system using Simulink. So here we will be modeling a quarter car suspension system. Simply put, this just means that we are modeling using 1/4 of the car's weight and using all of the components underneath the wheel well, including the suspension system, the tire, and the axle. So as you can see over here, this is a model of what we are actually building the equation for. So this is our model equation and the parameters that we will be using. I'd like to start out by going with the definitions about what each stands for. So M1 is 1/4 of the weight of the vehicle. M2 is the mass of the wheel, tire, and the axle assembly. K is the elasticity of the suspension spring. KT is the elasticity of the tire. And C has to do with the piston, strut, or shock absorber. They're all the same thing. F of T is the actuator force, and X of T is the road profile. So above you can see the two equations that we're using for M1 and M2. So the first equation is F minus K of X1 minus X2 minus C of X prime of 1 minus X prime of 2 is equal to M1 X double prime of 1. The second equation is negative F plus K of X1 minus X2 plus C of X prime of 1 minus X prime of 2 minus K of T of X of 2 minus XT of T is equal to M2 X double prime of 2. So the parameters that we're using are M1 is equal to 465 kilograms, M2 is equal to 50 kilograms, K is equal to 5,700 newtons per meter, KT is equal to 135 kilonewtons per meter, C is equal to 290 newtons per meter, F of T is equal to 1 newton, and X of T is equal to sine of T. And we will be changing some of this around later to see what everything does. So this is the block diagram modeling with X of T equal to sine of T, which we modeled by dividing the first equation by M1 to get X double prime 1, and then divided the second equation by M2 to get X double prime of 2. This is the scope of the model where we used xt equal to sine t, and this represents the velocity with respect to time. I included a sine curve so that you can see how it references to that. This is the scope using the x of t equal to sine of t, modeling position with time. And this I also included a sine curve so that we can see how it references to that. This is the scope using x of t equal to 1, where we simply change the road profile a bit. This models the velocity with respect to time. And it is also important to notice how close to a sine function this looks like. In this slide, we also modeled x of t is equal to 1, and this time we modeled it for position with respect to time. At the top, I modeled with simply position from time to 50, and in the bottom, you can see that I modeled up to 40,000 seconds. And as you can see in the bottom left-hand corner, it tries to approach 1. In this model, we used the original equation, but we changed M1 and M2, so it went back to x of t is equal to sine of t. So now our M1 value is equal to 1,500 kilograms, and our M2 value is equal to 161.29 kilograms. And as you can see, this looks very different from our original model. Where in the last slide we modeled the velocity with time, this time we are modeling position with time, and this is still with the M1 and M2 values changed, but with x of t equal to sine of t. And as you can see, this one does not look like our original model either. On this slide, we are modeling using the same M1 and M2 values as we did in the last slides, but we are also changing the K value, KT value, and C value to be proportional to the original equation. And as you can see, even with the changed M2 values, it comes out to be the same equation as we had originally, even with a smaller weight. Whereas in the last slide, we were modeling the velocity with time, now we are modeling position with time, with the modified values that are proportional to the original equation, even with the larger M1 and M2 values. So as you can see, this looks very, very similar to the original equation as well. In this slide, we are showing the modified M1 and 2 values compared to the original equation. So on the left, we have the modified M1 and M2 values without changing the other parameters. In the middle, we have the modified M1 and M2 values while changing the other parameters to be proportional. And then in the last one, it shows the original model having to do with the original equation. As you can see, the last two look virtually the same. Whereas in the last slide, we were modeling the velocity with respect to time. In this slide, we are modeling the position with respect to time. And as you can see, it is the same idea where the middle and the right scope are virtually the same. In conclusion, through looking at these scopes, we have found the importance of making sure that you have the right suspension components for your vehicle based on the weight. If you do not, they will not perform correctly. We were also able to see how changing the x of t value affected the equation. And these are my references. Thank you so much.